October 16, UPI. The team of gravity wave hunting scientists working with the LIGO and Virgo detectors announced the first observations of a collision of neutron stars, an unprecedented discovery, at a press conference on Monday. Astrophysicists detailed the groundbreaking discovery during a pair of simultaneous press conferences at the National Press Club in Washington, D.C., and the headquarters of the European Space Agency in Garching, Germany. Both press conferences were streamed live. Scientists shared evidence of a massive and violent collision between two dead stars. It's the type of giant collision, a cosmic forge, that scientists suggest can offer tremendous insight into the evolution and chemistry of the cosmos. The collision and others like it supplied the early universe with the smorgasbord of heavy metals and other compounds that make galaxies and planetary systems what they are today. I can't think of a similar situation in the field of science in my lifetime, where a single event provides so many staggering insights about our universe, Daniel Holes, an astrophysicist at the University of Chicago, said at the press conference. Last month, scientists pinpointed the origin of a gravity wave created by a faraway black hole merger using data collected by the two laser interferometer gravitational wave observatory detectors in Louisiana and Washington, and a single Virgo detector, located outside of Pisa, Italy. Unlike black hole mergers, which are void of visible light, neutron stars can be observed with regular telescopes. But until now, astronomers hadn't been able to find a merger to observe. Now, LIGO and Virgo have made it possible to quickly identify potential sources of intense collisions by triangulating incoming gravity waves. Most recently, the two interferometers identified a unique source of gravity of waves and informed observatory operators to point their telescopes in the direction of their discovery. The observations revealed the fireworks created by the collision of two dead stars, each roughly the size of New York City but packing as much mass as the sun. Whenever first detection happens, there's gonna be a party, no question, MIT astrophysicist Scott Hughes, who wasn't on the LIGO team, told Gizmodo shortly after the first LIGO discovery. But after that, when detection becomes routine, is when things start getting really interesting. The Hubble Space Telescope was one of several to participate in one of the largest multi-telescope observing campaigns ever. They discovered a blast of light where none existed before in the lenticular galaxy NGC 4993, locate 130 million light-years from Earth. Scientists watched the aftermath of the collision for 6 days. Their telescopes spotted material being ejected at the speed of light, and also revealed fading emissions over the 6 days, as predicted by computer models. It was surprising just how closely the behavior of the kilonova matched the predictions, Hubble scientist Niall Tanvir, professor at the University of Leicester, said in a news release. It looked nothing like known supernovae, which this object could have been, and so confidence was soon very high that this was the real deal. Though the ongoing analysis of the neutron-star collision is sure to yield a variety of surprises, many scientists were amused by the familiarity of the event. Even though this was an event that had never been seen before in human history, what it looked like was deeply familiar because it resembled very closely the predictions we had been making, Daniel Casson, a theoretical astrophysicist at the University of California, Berkeley, told NPR. Before these observations, what happened when two neutron stars merged was basically just a figment of theorists' imaginations and their computer simulations. Hubble was able to observe the neutron star collision across the entire infrared spectrum, revealing spectral signatures suggesting the production of heavy metals like gold and platinum. While the initial observations by LIGO were exciting, astronomers were confident even more monumental revelations would materialize once astronomers paired the interferometers with other astronomical instruments. The combination allows for so-called multi-messenger astronomy. Now, astronomers won't just look at the light from an object, as we've done for hundreds of years, but also listen to it, Tanvir said. Gravitational waves provide us with complementary information from objects which are very hard to study using only electromagnetic waves. So pairing gravitational waves with electromagnetic radiation will help astronomers understand some of the most extreme events in the universe. Monday's press conference confirmed early rumors that the announcement may not be related to the detection of a gravity wave but rather evidence of another dramatic phenomenon like the collision of two neutron stars. Gravitational waves are ripples in spacetime caused by ultra-powerful cosmic explosions. These waves bend and stretch spacetime. Over the last year and a half, gravity wave detection has become fairly routine. Several dozen gravity waves have been detected, and scientists are now tracing the waves to their point of origin with more accuracy. LIGO scientists held their first press conference in February 2016 to announce the first detection of a gravitational wave. Earlier this month, a trio of LIGO scientists was awarded the Nobel Prize in Physics. Astrophysicists Rainer Weiss, Barry C. Barish and Kip S. Thorne earned the prize for their decades of work designing and building the LIGO detector, enabling the observation of minuscule perturbations in the space-time continuum.